in this lesson, we're going to continue with probability, but we're going to use these things called arrays for two-step equations. Two-step, like probability equations. Now what it is that a two-step array, so we're looking at two-step experiments and we see different combinations. Obviously from examples you'll get a better idea, but essentially it's not just one thing. It's not just like, oh, what's the probability of rolling 1 6? It's two different things. So let's go for it. Let's look at the lesson. Okay, so we've got 3 students and they can win first and second prize. So we're going to have a look of how we can set this up with an array. So we can put first prize here and second prize on the side, on this side as well. And there's 3 students, so let's give them names. Stacy, alright, Bob, and Jesse, alright. So we've got 3 people, Stacy, Bob, and Jesse, and I'm going to use just their first letter to describe them. Alright. Now what I can do is I can just set it up using their names. So I can use S, B, J. Alright, and then S, B, J. Alright. So what happens here is that these are the different combinations we can get. If I just follow this down here, I can get 2 Stacys. Alright, so she could win first and second prize. Or I could go here, Bob, and Stacy, if I just follow the same sort of thing. And the last one would be Jesse and Stacy. So once again, we're following from J to S. Okay? And then I'm going to do this all the way down. Alright, so I'm going to go S, B, because I'm going S, B. Or I can go B, B, which means Bob wins first and second prize. Or I can go Jesse, Bob. And finally I can go Stacy, Jesse, Bob, Jesse, and then Jesse, Jesse. Alright? So what this does, it clearly tells me what all the combinations of 3 students, given that there's a first and there's a second prize. Okay. Now, if I had a question that said, how many outcomes are there? So I just count them all up. 1, 2, 3, 4, 5, 6, 7, 8, 9. So there's 9 different outcomes. Okay. There's 9 outcomes. I'll put it in a different color. Okay. And then you can ask the second question. What if we can't have the same person win first and second? Alright. How many outcomes are there? So same question, how many outcomes are there? What if we go, how many outcomes are there? Well, that means we have to get rid of all these doubles. So how many outcomes are there now? There will be 6 outcomes. Alright. So what these arrays do, they do a really quick thing of when you've got 2 scenarios. So in this case, the 2 scenarios are first and second prize of 3 different people. Alright, let's go to a second example, and it's a 6-sided die. And what we're going to do is that we're going to represent it in the same sort of way. So I'm going to start with 1, 2, 3, 4, 5, 6, and then here 1, 2, 3, 4, 5, 6, and I'm just going to move quickly. I'm going to do the same. I can roll 2 1s, or 2 1, 3 1, 4 1, 5 1, 6 1, and I'm just going to keep going because because we've got a lot to write down. And hopefully you're doing this with me, because I'm not pausing the video. So and we go 1 4, so we can go either way. And 1 6, we go 2 4, 2 5, 2 6, 3 4, 3 5, 3 6. So in all of these, there's a certain pattern that occurs. So I'm changing my pattern all the time, so I apologize for those that this is very frustrating for. But yeah, for me, it seems to be okay. And then 5 5, 5 6, and there we go, 5 6. This one I did wrong, didn't I? So that's 6 5, and then this will be 6 6. All right, so that represents all the rolls that I can make with 2 die, and have a look at them. I can get 2 6s, a 2 and a 3, a 3 and a 3, 4 and a 2, so different sort of representative. It represents all things with 2 6-sided die. Now, list all the outcomes on the table. We've just done that. How many outcomes are there? Well, it's going to be 6 times 6, so the total amount of outcomes is 36. And it says find the probability of getting a double. I don't know if you noticed this pattern when we were doing it, but there's doubles all the way in the middle here. And how many of them is there? 6, all right? So probability of a double is 6 over 36, and that actually reduces to 1 over 6. And you can ask an infinite amount of questions with this, but I've just got one more for you to do. Find the probability of getting a sum of less than 7. So that's adding up to get less than 7. 1 plus 1 is less than 7. 2 plus 1 is less than 7. 3 plus 3 is less than 7. Now 7 is not less than 7. It's actually equal to 7, so we can't include that. So what ends up happening is that we end up getting everything. Can you see this pattern that I'm colouring in now? We end up getting all of this here and everything else. So if you look, I'll use the highlighter. This line here, I didn't do it properly, but is equal to 7. So we have to get everything on this side of the line. So let's count how many there are. There's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. It actually works out to be half of them. I mean, a bit less than half of them. So I go less than 7. So it's going to be 15 over 36. And I think 3 goes into both of them. Simplest way to simplify is on your calculator. And we get 3 goes into 15 5 times. And 3 goes into 36 12 times. I'm pretty sure I'm right with that. So hopefully that helps. I think that's the end of that. So peace out.